In this activity, we are observing the charging and discharging behavior of a capacitor using a battery and a multimeter. Initially, the capacitor is connected to a battery, allowing it to store electrical energy in the form of an electric field between its plates. This process is called charging of a capacitor. After charging, when we measure the potential difference across the capacitor using a multimeter, we observe a voltage of around 0.7 volts. However, this voltage does not remain constant. It gradually decreases with time, indicating that the capacitor is discharging. This discharge occurs due to leakage current and the internal resistance of the circuit, which allows the stored charge to slowly flow away. In an ideal capacitor, the charge would remain constant, but in practical situations, especially with simple or homemade capacitors, energy loss is inevitable, leading to a drop in voltage.
This is the multimeter. So first we should change the knob to 20 volts. First we can check the volt of the battery. So the volt is shown, it's 8 volt. Now we can take the capacitor we made and connect it with the charger and battery. So the capacitor is getting charged for some time. Then we can take the battery out and connect it with the voltmeter. So the multimeter shows it's discharging.
Can you just show it in close-up?
So the capacitor is getting discharged.
Okay. Capacitors. Okay, so 4 capacitors together. So it is in what connection? The series connection. Now I'm going to charge this. So as I charge the capacitor now, okay, one is connected to the other, one end of the that is capacitor connected in series. The other one I'm charging now, and once it is done, I'm just going to show it in the multimeter. See the charge. It is more than 1 volt. So since it is 4 capacitor, it is more than 1 volt. If it is more than 4, you can also increase the storage capacity. Now it is reducing. Multimeter. See, nearly 3 volt is being stored, and now it is discharging. The discharging is fast because we have connected in series, so capacitance value will be lesser compared to parallel connection. Okay. Yes, so now we'll try to make a LED glow with this voltage.
When the circuit is completed, the capacitors discharge quickly, giving a short pulse of current. That is why the LED flashes once and then turns off. Since the capacitors are connected in series, the total capacitance decreases, so the stored charge is even less. As a result, the LED cannot glow continuously.